welcome to this deep dive. Today we're digging into a really interesting piece from Black Knight Power.
Yeah, it's titled Rain-Powered Solar Panel in Delaware.
Exactly. And it covers this, well, pretty innovative tech. Solar panels that work with sunlight, obviously, but also generate power from rain.
Uh-huh. It's quite a concept.
So our mission today is really to unpack how this works, why Delaware is the focus here, and what it could mean for renewable energy reliability overall.
Okay.
Right, let's get into it. Because you usually think solar panels, clouds roll in, production drops.
Mm-hmm.
But imagine they actually start generating power because it's raining.
Yeah.
That's where it gets really interesting.
It really does. The key piece of tech here is an extra layer they add to the panel. The source calls it a triboelectric nanogenerator, TENI for short.
Tenyang. Okay,
Yes.
triboelectric.
Yeah.
What does that mean in simple terms?
Well, tribo relates to friction. Think static electricity, maybe. When raindrops hit this special 10 layer, the friction, the contact between the water and the surface,
Yeah.
it creates a small electrical charge. And the system captures that charge.
Huh. So it's literally using the impact and movement of the rain, friction power, kind of.
Exactly. It's harnessing that kinetic and electrostatic energy. But it's important to note, it supplements the solar power. It doesn't replace it.
Right, so it's an add-on. So on those gloomy, rainy days where normal panels dip.
This tang layer kicks in and adds some power, so you get a boost exactly when solar generation is low.
That sounds like the main selling point then, making the output more consistent.
Absolutely. That increased generation during bad weather is crucial. You get this dual source sun and rain. It enhances the overall sustainability and potentially leads to better long-term savings by making you less reliant on the grid during those times.
Okay, and the source specifically points to Delaware. Why there? What's special about Delaware's climate for this?
It seems to be the rainfall pattern. Delaware has a humid subtropical climate, gets around 45 inches of rain per year. And critically, that rain is spread pretty evenly throughout the year. It's not all concentrated in one season.
Ah, so you get frequent, sort of moderate rain events rather than just occasional downpours.
Exactly. That consistency gives the 10-layer regular chances to generate power, especially on overcast days when traditional panels aren't doing much.
Makes sense. So even though they have other weather, like snow or hurricanes, it's the steady drip, drip, drip that makes it suitable.
Huh. Yeah, you could put it that way. It leverages that common weather feature.
Let's talk cost. Always a big factor with solar. How does this tech compare price-wise, according to the article?
Right. So traditional solar. The source gives an average for a 10-kilowatt residential system in Delaware, maybe around $33,610 before any incentives.
And with the federal tax credit, that 30% one?
That brings it down to roughly $23,500 or so net cost.
Okay. And the rain-powered version?
Well, it's expected to cost more upfront. The estimate in the article for a similar 10-kilowatt system is closer to $40,000.
Wow. Okay. So even after the federal credit, that's maybe around $28,000 net?
Yeah, something like that. So it's definitely a higher initial investment. That's a hurdle.
For sure.
But the argument, is that the extra energy you generate over the years, especially during rainy periods, could offset that difference through lower bills long term.
Plus, are there state-level incentives mentioned?
Yes. Delaware has things like its Green Energy Program grants. The source says those can be between $2,000 and $6,000, which would certainly help lower that initial cost burden.
Okay, that helps bridge the gap a bit.
Yeah.
Now, the source also mentions a really cool example at the University of Delaware, AgriSolar.
Yes. That's fascinating. They're using horizontally set up panels. And these panels are doing two things.
Okay.
They're generating power, apparently hitting 80% of their rated output even in bad weather, which is impressive.
80%? Wow.
And at the same time, they're acting as a shield, protecting the crops underneath from heavy rain.
Wait, so they're generating power and providing physical protection, like a 2-for-1 deal.
Exactly. It's a perfect example of this dual utility idea. Shows real versatility beyond just electrons.
That's really smart.
Sure.
So where else could this apply in Delaware, thinking beyond just farms?
Well, residential rooftops are obviously a big market. Maximize generation on limited space, maybe benefit from net metering.
Right.
And then commercial buildings, industrial sites, anywhere that needs reliable power, especially during storms, and might even value that protective aspect for equipment or operations.
So given all this potential, what are the main roadblocks right now, according to Black Knight Power?
It really comes down to two main things we've touched on. that higher initial cost is still a factor.
Mm-hmm.
And currently, these specific rain-powered panels just aren't widely available yet in the U.S. market. It's still emerging technology.
So the outlook, what needs to happen?
Like with most new tech, costs should come down as manufacturing scales up and research hopefully improves efficiency further. Availability should increase over time.
Okay, so let's wrap this up. This rain-powered solar concept seems genuinely promising, especially for places like Delaware with that steady rainfall pattern. It could really boost energy reliability.
Yeah, the key points are the climate fit for Delaware, the role of incentives in managing costs, and these really interesting dual-use applications like we saw with the UDEL AgriSolar project. It's not just about power.
Right, and that makes you think. This technology isn't just an energy source. It can actively do something else useful, like protection. It raises a bigger question, really. If renewable tech can serve multiple purposes, where else could we see these kinds of dual utility solutions pop up, tackling different problems at once? Something for you to think about.